Well, hi, my name is Peter Shannon, and I'm the founder of Radius Capital, an early stage venture firm focused on investing in really the enabling technologies and the systems that tie together advanced aerial mobility and how advanced aerial mobility can make an impact on the transportation landscape, really across industries and across the economy. So to introduce a little bit about how we approach the space, how we see the opportunities emerging in this space, I'll take us through a sort of broad introduction of the context of technology's impact on transportation, and then we'll go into more of the details of how we see the opportunities. One of the first insights that we bring when we try to frame all of the activity that's going on across this space is that life is built on movement or on mobility, so to speak. Our transportation capabilities really have such an impact in defining where we live, where we work, the opportunities that we avail ourselves to, and how we define the everyday aspects of our lives. Transportation in very powerful, but also in some ways very subtle ways, shapes those. And as we know through the travails of modern life, of long commutes, of high real estate prices, that in fact, transportation today has limitations, it has points of pain. And we see lots of technologies, especially over the last decade, working to do innovations in mobility and to address those and give us new options. One of the things that we really see is that the continued impact of software systems being woven into our physical world systems are really creating potential for fundamentally new types of mobility, new modes of transportation across the landscape. And this is driven by maturation of a number of categories of emerging technologies, whether in electric propulsion, whether in big data and AI, whether in sensing systems, or the software that ties all of these things together into scalable mobility systems that people and that businesses can use to change how they work. And we really invest in that set of enablers and that space. Our area of focus is mobility in the air. We believe that this is both a really attractive proving ground for these technologies. The aviation is an area that has a proven track record of incorporating automation and incorporating new technologies incrementally to advance the capability in the airspace system. And these same technologies that are being matured here, not only are they going to have a huge impact in how we use flight to get things done across the economy going forward, but these same technologies are creating a generalized capability for making robots successful out in the physical world. That's really the broadest way that we can think about it. It is going to impact our ability to shape ground mobility and to bring this technology into other applications around mobility and logistics that we haven't even yet conceived of yet. So we are focused in the aerial mobility space. We are thought leaders in this space. I serve as an appointee to NASA's Aeronautics Research Technology Roundtable. This is a group of people from industry who give feedback to NASA and help answer the questions of how can NASA leverage its unique position, its unique assets to make a difference and to promote U.S. industrial leadership in this new frontier of aviation, of advanced aerial mobility, and have continued to serve in that capacity. I'm also a co-author of a national strategy for advanced aerial mobility. This was done at the request of last year, a committee of 12 of us through the National Academies of Sciences. And in that report, we laid out a vision for what advanced aerial mobility can be. We looked at the airspace system today and the underlying technologies today versus what it needs to mature to in the future in order to realize that vision. And we also spent a lot of time looking at the systems engineering challenge across the airspace system for how we get there, and how do companies in the private sector work with organizations in the public sector in order to really take this in a coordinated way to achieve this vision. There's a lot of bridging across private sector and public sector that is going to take place, that's going to need to take place for us to be successful here. And what we really look at is fundamentally these technologies around electric propulsion, around increasing automation towards autonomous systems, ubiquitous connectivity. These technology drivers are really, in a way, redefining how we think of flight, how we think of the capabilities that flight can have, and therefore what form it can take and how we might employ it in the future. So these technologies are delivering a number of different dimensions of benefit to flight, around reduced complexity, increased safety, the ability to achieve both vertical and horizontal flight, and to do so in a way that with a much lower noise signature than 20th century technology could have offered. These technologies are also enabling us to scale air vehicles down to very small sizes and up to full-size aircraft that might carry multiple passengers or large amounts of cargo. And the elegance of the new architectures that this technology is enabling really allow that scalability in a way that we didn't have access to on 20th century technology. So we look at this and we see that applicable flight to broaden tremendously. When we look at our investment opportunity set, it spans across the enabling technologies that are common to all of these different types of flight, as well as the technologies that digitize the flight environment, that tie air vehicles to infrastructure and to the airspace system as a whole. Many of these are very scalable technologies. Many are software-based technology. But there are also some very important innovations in propulsion and in the manufacturing approach, the industrial base that we build to be able to produce these vehicles at aerospace grade quality, yet also at high scale, and to do that with new processes and new materials and new approaches towards the entire arc between design, manufacturing, quality assurance, and then supporting those products out in the field. So we really see a whole host of very exciting enabling technologies that span beyond air vehicles themselves. And these technologies naturally have a lot of additional applicability to mobility and applications outside of just the aviation environment. We spoke a little bit about the national strategy that my committee and I worked on last year. We published this just in February of 2020. And this report is available free for download from the National Academy's Press website. And it covers a lot of that arc around where we sit today, the vision we have, how we get there. But it also gets down to some specific recommendations of areas of standards development, areas of research, and areas of integration between public sector and private sector to try and give the community some really actionable things that we can be working on in the next few years to try and move this forward and to try and build consensus and get the first iterations of this technology certified and flying and making a difference in the airspace system. When we look at what we're doing in advanced aerial mobility, it's valuable, I think, to reflect it against the historical arc of transportation broadly and of aviation specifically. This is one of the most exciting periods of time in the aviation industry. It's not the only one, though. We've seen periods like this in the past, and one that specifically comes to mind is the period of time following 1927, when Charles Lindbergh made his famous journey across the Atlantic nonstop from New York to Paris. That event really electrified the world. It brought a lot of entrepreneurs into the aviation space. It brought a lot of investors into the space, and it gave the general public a sort of a really tangible example, and inspired them to understand, to begin to think about the ways that aviation could impact their lives in the future. Aviation was, had been around for decades, but it had been still a little bit elusive in the public's eye in terms of what it would really mean for them. And this event, really, by connecting those two cities and showing what aviation could do, was very pivotal. And the 1930s following this were one of the most vibrant times of innovation in aviation. And a lot of the visions that we have today for advanced aerial mobility were actually also there back at that time. It was just, a bit early for the technology. But in the 20th century, we made tremendous progress. I mean, unbelievable progress with the technology and with incorporating flight into our lives. Now, principally, that was in the area of commercial aviation. And in commercial aviation, we've changed the world, but we've done so in a relatively narrow use case. Moving people long distances between large cities using large aircraft that are efficient at high altitude and in long distance flight, in no small part courtesy of the development of the turbofan engine, and managing the complexity of the system through a very refined approach to highly trained professionals operating the system both in the cockpit as well as managing the air traffic system wide. And that worked for commercial aviation. We made the economics work. We made getting around the world long distance something that was affordable to the middle class globally, a huge impact. What we're looking at ahead now is a much broader applications that extend beyond that long distance passenger transport on set routes to a much more flexible type of transportation that really falls into this category of mobility, of the notion of people using this type of flight to move goods or to move passengers on a ad hoc, more spontaneous basis, and between a much finer grained set of points of origin and destination. And that type of mobility really falls into line with the historical arc of how mobility has impacted our lives, and really the fact that mobility has shaped the very cities that we build. When we look further back into history, we look at the progression of transportation mobility from being on foot or on horseback to the introduction of rail transportation, urban rail transport, trolleys, subways, and then later the introduction of the automobile and the impact that that had. At each step, we saw the nature and the footprint of cities begin to change gradually over time in the wake of that technology. Cities increased in radius, in their size, and people were able to change their movement patterns within them. One of the interesting constants that we've seen throughout this arc has been that people have, very interestingly, really been willing only to allocate a certain number of minutes per day to their routine movements around town, their commutes, so to speak. And that has been roughly 60 minutes round trip. And you can see that in the size of cities. You can see that in other records that are available. And every new technology has increased that, and advanced aerial mobility is going to be another step in this progression. And so this slide sort of gives us a feel for that time arc. And just like with so many aspects of technology in the modern age, things are changing faster. And in the software revolution that we've been experiencing, let's say the last 30 years, that pace has picked up and it's having an impact on mobility. We see the impact of the smartphone and digital maps and how those have changed how we think about moving around, the new business models that are built on the back of that with ride sharing, and more recently, the pioneering work to bring self-driving cars, and of course, drones and advanced aerial mobility into the space. These are all going to be having a imminent and profound impact on our future cities and on our future movement patterns. And to illustrate that, we can look at the comparison between what we can do with automobiles today. This is a map of my hometown of the San Francisco Bay Area. And what it shows is if you were to depart from the middle of San Francisco on an average day, and you were willing to drive up to 60 minutes in a car, how far could you get? To what land area could you reach in that journey if you went in any possible direction? And that's determined by the structure of the road network, and it's determined by the average traffic congestion. And that's what this shaded area shows you. This shows you the reach of automobile transportation in the Bay Area. And of course, for anyone who's actually lived in the Bay Area, you would say this is optimistic. At certain times of day, you can't even get this far in 60 minutes, but this data is blended across 24 hours. And if we overlay that with aerial mobility, with the ability to get up into vertical space and then to go where you want to go, and if you allow yourself 30 minutes by air, what is the land area that you can reach? And you see here, it's this blue shaded region. It's a profound difference. It's a profoundly larger area of the greater metropolitan region that suddenly is brought into play, that is brought into the economic interactions of the city and also the social interactions. Once we master this technology and once we find ways to integrate it into the airspace system and scale it up, the long-term, the multi-decade implications of this technology are going to reshape our concept of cities. They're going to reshape our concept of where we choose, where it's possible for us to live and to work, and really our perception of the time and space around us. What is considered nearby? What is considered close? What are the places that we can casually travel over to versus the things that are a special trip that we plan days in advance? Aerial mobility is going to have that type of an impact. And one of the things that you notice in that data that we just looked at is that ground transportation is dependent upon roads. It's dependent upon these linear paths, this concrete and asphalt infrastructure that we lay down. And when we do that, we have to maintain it. It's expensive. When we do that, we're making a very long-term commitment to the routes and therefore to the movement patterns that we're going to enable people to take because they can only go where the roads go. And that has very long-term implications. Aerial mobility doesn't use roads. It doesn't use ground path infrastructure. Once you can get up into the air, it is possible to go in any direction and get to any destination directly. This is a very important concept to think about as we think about how we deploy aerial mobility in the early days and as we think about its ultimate impacts. And so this transition from ground transportation to including aerial mobility as sort of an overlay on top of ground transportation, this flexibility, this idea of a network that doesn't require all that path infrastructure, we call these nodal networks. In fact, the paths that we are defining between these points are paths in the airspace. They are really defined in software by the structure of our airspace system. This is a fundamental and very powerful difference, and one that has a lot of potential for the initial applications that we introduce, and then also for the challenges of figuring out how do we scale this up? How do we do so safely? How do we do so in a way that meets all of the needs of society? As a primer, I'm sure people with an interest in this space know this, but this is at a point where lots of prototypes are flying today. All of these air vehicles pictured here are in the air in some degree of flight testing. We've moved beyond the purely conceptual level with this technology, and we are learning very, very fast. Really, every year, the technology around the configurations, around the subsystems is advancing very quickly. And really, the more time that we spend in the air, that is the most valuable way that we can learn and that we can advance the state of the art in this technology. And as you see, these air vehicles have radically different configurations. And that is indicative of the state of innovation in this space. Electric propulsion and these new control systems that have come in have really opened up new dimensions of design possibilities for these types of aircraft. And entrepreneurs and engineers across the spectrum are exploring the potential. They're exploring what are the most efficient, most capable configurations, the safest configurations for different types of missions and different types of aircraft performance profiles. So it's a very vibrant time. It's a very exciting time in the space, and we're going to see, even yet more of these different types of air vehicles take to the air and learn more about these. We've seen a lot of reports around the size of this opportunity. The numbers are very large out in the future once we are able to employ this technology for moving people or for moving cargo in large amounts. Most of the focus around these market sizing analyses have been on the urban air mobility application. That's it's a very high potential application. It's also one that demands quite a lot of the technology, and we'll talk about that in a few minutes. At Radius, we have worked really hard to frame this opportunity, to really explain the broad scope of it, the historical context, and the really sort of foundational impact that it's going to have on how we think about mobility and how that affects the economy and how it affects society. And we've published a series of articles over the last couple of years on this space, and those are available for anyone to read on our site at Medium and also on our firm's website. When we think about the application space, one of the things that we really embrace is that the applications are so broad for this technology. And the way we look at the space is we look at drones right alongside eVTOLs, right alongside electric airplanes. We see it all as one trend driven by common advances in technology. We see applications not just in urban areas, but across rural areas. We see applications to move cargo or goods just as much as we see moving people. And urban air mobility is really just one of numerous potential applications out there. It receives a lot of attention, and rightly so. But before we get to the technology maturity levels that enable us to do the public-facing air taxi type of a model, we're going to probably traverse quite a number of stepping stones, earlier applications that are less demanding of the technology and that are operating in these other sectors and these other operational models. And one of the things that we feel pretty strongly about is that once these air vehicles, once this technology gets into the hand of customers, it's the customers who are going to show us where the killer applications are. They're going to show us how they want to use it, because the customers have unique insights that we'll never have in terms of their locale, the ways that they want to employ it for mobility. their business and how they want to be more competitive with their business or be more efficient with their logistics using aerial transportation of people or of goods. Their unique insights are going to lead us to applications for this technology that we in the aerospace community simply don't have the information right now to see. We don't have the insights to see that. But if we get into the air with these vehicles and we give the community, even if they're small, if they're relatively simple air vehicles, we put them into their hands and give it to them in a way that is flexible, that is multi-purpose, then they are going to be able to deliver back to us tremendous insights into the future directions of what these stepping stones look like, so that we scale up this industry, so that we build more experience, build higher performing, safer air vehicles, and get the airspace system itself up to the level of scale and capability in order to do this very dense, highly automated urban air mobility application on the back of it. So we see, investment opportunities really across the whole arc of enabling technologies that are available today, applications that are imminent, and the systems that tie all of these different things together. We do feel that we're at the beginning of a 20 to 30 year cycle in this space, a long-term transformation. Additional investment opportunities are going to unfold and avail themselves over time. Our challenge is working through and finding the ones that are actionable today. But sitting here at the beginning of this type of a change in the aerospace industry, this new wave, is a tremendously exciting thing and a very vibrant time to be working in the space. So I hope that this overview has been helpful in integrating together some of the different things that we're all seeing out there, tying them together into a picture and into a path forward, and bringing some insight into what we're seeing today and the future implications that it will have, and what that might mean for opportunities in the future. So thank you very much, and I look forward to providing more feedback.